Okay, so today we're going to be reviewing some stuff. We will be reviewing today operations with integers. Couple of things. One is that when we review something like this, it's because probably in the next class we're going to use it. Okay? Second thing, I'm not trying to insult anyone's intelligence here. Okay? There's going to be some of you who are like, oh gosh, I can't believe we're reviewing this. But for some people, it's necessary. So if for you, you're like, I'm way beyond that, that's not a big deal, I ask your indulgence. For those of you who need this, this will hopefully be a good review for you. And this is stuff that you actually did in junior high math. Okay? But we're doing all this without a calculator this semester. So you have to get good at it if you aren't already. Any questions about that? One last thing before we go on with the rest of the lesson. In case you missed it, I have been put on a jury for a murder trial downtown. So today we have the day off, but then I'm back on Monday, and I will, in all likelihood, not be with you Monday or Tuesday or Wednesday. Okay? So I'm going to be recording lessons. So please bring earbuds or headphones so that you can listen to an explanation of the homework. There'll be a video that explains the homework problems, and there'll also be a lesson each day. Okay? My plan is, I don't know if it'll happen every day, but it certainly will happen Monday, that I'll be here before school because I don't have to be downtown until 10 o'clock. I'm probably going to teach my first period class and then leave. So if you have questions or you need help with something, whatever it is, plan on coming in before school on Monday. Okay? We have a quiz coming up on Wednesday. We're still having that quiz. Life goes on. So if you're having questions on stuff from either the homework that was due on this week Wednesday or the homework that was due today, you should come in and get those questions answered before Wednesday. Okay? Everybody clear on that? All right. Yes, sir.
So the whole this lesson right now, is it going to be on a quiz on Wednesday?
No. The quiz on Wednesday will cover the homework that was due, the worksheet that you guys turned in on Wednesday, and the homework that was turned in today. Just those two things. Good question. All right. So operations with integers. So we're going to do addition. We're going to do subtraction. And again, I apologize to anyone who's like, this is baby stuff. If you feel that way, great. You're going to zip through the homework and this is not going to be a problem for you. But I find that there's always a couple of students who have forgotten how to add and subtract positive and negative numbers. So we're just going to spend a day going over it. All right. Addition. First of all, if you have like signs, when you added two positive integers, that was one of the first things you learned in elementary school. You did things like 7 plus 8, which is anybody or everybody. What's 8 plus 7? 15. Or 23 plus 34? 57. So when we add two positive numbers, we get a larger value, don't we? Same thing happens when we add two negative numbers. These are working together is the way I think about it. They're both negative. They both work together when we add them. So for this, negative 8 plus negative 5, I just think about it as what's 8 plus 5? 13. That's okay. 8 plus 5 is 13, but it's a negative plus a negative, so we've got a lot of negative. This is negative 13. And then negative 37 plus negative 24. Negative how much? 61. Very good. Negative 61. So let's write out the rule here. When adding two numbers with the same sign. Add the numbers and keep the sign. Okay? I think that's the most straightforward kind of problem. It's addition. Almost everybody's better at addition than they are at subtraction, or at least I am. Let's go on to what if there are unlike signs? So there's a whole bunch of different ways you can visualize this. Until this year, the last 6 years, I've taught pre-algebra to 7th graders. So that's where you do, we actually do 7th grade math and pre-algebra all in 1 year. It really goes by fast. But one of the ways we taught people to visualize things was to do pluses and minuses. So for example, this one, if we have 6 plus negative 8, if you really got stumped on this, you could go, okay, I'm going to make 6 plus signs and 8 negative signs, and then these all zero out. A negative and a positive adds out to 0, adds out to 0, adds out to 0, adds out to 0, adds out to 0. Leaving me with what?
-2.
Yeah, I have 2 negatives, so the answer is -2. Now, that's fine when it's 6 and -8. But if it's -43 and positive 257, that's not going to work very well, is it? You could spend a long time just drawing those. All right, for this one, let's draw it just for fun, and then we'll talk about how can we do this without having to draw these out. So 9 pluses, 3, 4, 5, 6, 7, 8, 9, and 4 negatives, 1, 2, 3, 4. That all makes one big fat 0. I've got 5 positives still left, so this is +5. All right, before we turn the page, let's talk about how we could do this without having to draw all that. So, if I'm just looking at 6 and 8, forget about the negative for just a second. If I'm looking at 6 and 8, how do I get 2? Yep, you subtract 8 minus 6. If I have just 9 and 4, again, forget about the negative for just a second. If I have 9 and 4, how do I get 5? Subtract 4 from 9, or 9 minus 4. So in both of these cases, it seems like even though it says to add, we're subtracting. Why? Because a positive number is trying to go one way, and a negative number is trying to go the other way. They're working against each other. So a lot of it cancels out. So we subtract. How do we know which sign we're going to have? How do we know that this one's going to end up being negative and this one's going to end up positive? Yes, sir. There's 2 negatives. There's only 1. I'm talking about if you. You're talking about the diagram. I'm talking about if we were just looking at this.
The negative number's bigger.
Yeah, the negative number's bigger. There's more negative than there is positive. Okay, so let's turn the page. So this is all what we just talked about. How can we get these numbers? By subtracting. How do we determine the sign of the answer? Look for the larger absolute value. Which one is stronger?
Larger absolute value.
Pardon?
Larger absolute value.
The larger absolute value, exactly. That's the stronger one. So the rule here is we are going to, when we're adding two numbers with unlike signs, we're going to subtract the absolute values. So we're going to ignore any negatives and keep the sign of the larger absolute value. All right, so let's do some of those. So if I have negative 63 plus 97, I'm adding a positive and a negative. I'm going to subtract. I'll do that over here in the margin. And it's how much? 34. Is this going to be a positive or is it going to be negative? Positive. Again, there's more positive than there is negative. And we're combining those by adding. All right, same thing here. 28 plus negative 19. I'm adding a positive and a negative. So I'll subtract. What do we get? We get 9. This is going to be positive because there's more positive than there is negative. Again, we're adding a positive and a negative. So we'll subtract. 75 is the larger absolute value, minus 57. Let's subtract, let's see. That's going to be 8. That's going to be 18. Is it going to be positive 18 or negative 18? Negative 18, because there's more negative than there is positive. And then last one, 85 minus 46. Again, we'll borrow one here. That's going to be 9. This is going to be 3. Is it positive 39 or negative 39? Positive 39. There's more positive than there is negative. Okay. Have a question for everybody before we go on to page 3. Are you better at adding or subtracting? Almost everybody is better at adding than subtracting, right? I'm better at adding than subtracting, and I'm a math teacher. So if a subtraction is ever ugly or hard, I change it into an addition problem every single time because I'm better at adding than I am at subtracting. Why would I do the harder problem? One of my sort of lame jokes is that mathematicians are either some of the most efficient people in the world or the laziest people in the world because we're always looking for an easier way to do things. Okay? All right. So, if it's a simple subtraction, I don't change it. Right? If it's 8 minus 5, I just go, oh yeah, I know what 8 minus 5 is. That's 3. Or 23 minus 18, that's very straightforward. That's just 5. So if it's a simple subtraction, don't do anything with it. But anything else that's ugly, we can apply this rule. Since addition and subtraction are opposites, subtracting a number is the same thing as adding the opposite. Now, some people do things like L-chop and all those other kind of things, but I just go add the opposite. Yes, ma'am.
So with the examples on second paragraph.
Mm-hmm.
My teacher last year said that you can take both of the signs and like both of the negative signs and actually
Make
them
it a big
plus.
positive. I really dislike that, and there's a reason why, and it just comes up in some problems that gets kind of ugly. If you do it, there's nothing wrong with it. I have seen students use that at the wrong time, and so I don't care for it because some students start making mistakes because of it. But if you can do it and do it well, I'm all for it.
She would just go two negatives is a positive.
Yeah, and that's what I hate. Two negatives don't always make a positive. If I'm adding two negatives, do I get a positive?
No.
No.
That's what confused me at first, but then
Yeah, once you get it, but if you're, I'm all about trying not to confuse people if I don't have to. All right. So here, 8 minus a negative 7. Again, you can use the rule where you just make this minus a negative, make it a big plus sign, and that's fine. But you can also just write out, this is 8. I'm going to change the subtraction to a positive, to a plus, and change the negative 7 to its opposite, which is positive 7. So that's just 8 plus 7, which is 15. And it works all of the time. I like rules that work all the time. I don't like, well, you have to use this rule in this case, and this rule in this case, and this rule in this case. Those things, I don't know about you, but they drive me nuts. Right? Sorry?
it gets confusing.
It gets confusing. I like having one rule. Now, there are times when you can have one rule, but it's hard sometimes and easy sometimes. Then I'm all for, yeah, let's have a rule that makes it easier. Okay? All right. So here, negative 6 minus 5. Well, make that plus a negative 5. At the very least in your head, if not written down. I suggest if you're not good at it, write it down. This is going to be negative 11. And then negative 23 minus a negative 9. Well, that's negative 23 plus 9. I'm adding a positive and a negative. We just went over this. What do we do when we add a positive and a negative? We subtract. 23 minus 9 is 14. Is it going to be positive 14 or negative 14? Negative, because there's more negative than there is positive. All right, so then here, this will be negative 16 plus a negative 11. Notice I put that in parentheses. Although it's not technically speaking wrong to write it this way. Could somebody get confused by that? What do you mean plus minus? Okay, so I'm adding two negatives. Are those going to work together or work against each other? Are they on the same team? Yeah, they're going to work together. They're both negative, so I'm going to add those two together. And there's both negative, so this is negative 27. It doesn't take long to rewrite these. This is negative 47 plus the opposite of negative 8 is positive 8. Working together or working against each other? Working against each other. So I'll subtract 47 minus 8 is 39. And it's negative because? 47 is the bigger number and it's negative. That's negative 39. All right, please do the last 4 on that page on your own. Go. All right, let's see how you did on this. Nicholas, what'd you get for this one?
This one, I got 19.
19? Do I have any disagreement?
No.
All right, very nice. Ethan, what'd you get for 24 minus negative 15?
Let's get it a mistake. For the minus 53, minus 72, I made a.
Oh, wait, we're doing the next one. 24 minus negative 15.
Yeah, but I did at the place of subtract.
Okay,
Yeah, so I did 39.
39?
Yeah.
All right, any disagreement on that? Very good, thank you, sir. Liam, tell me about the next one. Just tell me your answer.
I got 54.
Any disagreement on that?
Yeah.
Yeah, it should be 52. So for you, I'm sensing there may be I need to slow down just a little bit. And honestly, I tend to be that way. I make a lot of minor mistakes. Unfortunately, they cost you. Okay? All right. And Joey, what'd you get for this last one?
Active 33.
Negative 33? Anyone disagree? Sweet. Let's go on to page 4. And let's see, this class is over at 24 after. We're going to have to hurry. All right. So here's an equation that we're going to start using next week. But I'm going to show you how to solve it this week so that we can use it next week. And you might as well start memorizing it. Okay, you don't need to know what these things stand for today, but you will on Monday's lesson. So, m is equal to half of e sub 1 plus e sub 2, or you just say e1 and e2. The first type we're going to do is the easiest type, the ones where we're given e1 and e2. So I suggest that you write out the equation every time. M is equal to 1/2 of e1 plus e2. We want to find m, so I'm going to write m equals 1/2. E sub 1 is negative 24, plus e2 is 18. Since those two, one's a positive and one's a negative, and I'm adding them, do they work together or work against each other? They work against each other. So what do I do?
Minus.
We're going to subtract. 24 minus 18 is 6. And it's going to be a negative 6, indeed. Because there's more negative than there is positive. So that's negative 3. That's the easy one. That's just using the things that we've been doing. Sometimes we're going to try and solve for E1 or E2. That's a little bit harder and involves some algebra. So let's look at this example. Find the value of E1 when M is negative 17 and E2 is 47. I'm going to write the equation. M is equal to 1/2 of E1 plus E2. Substitute in negative 17 is equal to 1/2 of E1 plus 47. I have two choices at this point for solving this. One is I can distribute the half. I'm not going to distribute the half on this one because half of 47 is not a nice number, is it? I'm going to get rid of the 1/2. How? By? Multiply both sides by 2. Exactly and perfectly said. You want to multiply both sides by 2. 2 times negative 17 is negative 34. 2 times a half is 1. So I've got 1 times E1 plus 47, so that's just E1 plus 47. I'm going to subtract 47 from both sides, so I have negative 34 minus 47 is E sub 1. If you need to make that an addition problem, do. Negative 34 plus negative 47 is E1. It's what? Negative 81. I'm going to try to do this other one. I'll show you that sometimes you can distribute and it works out fine. Last one. M is equal to, actually, don't worry about trying to write this down because I'm going to write really fast. So this is 63 is equal to 1/2 of negative 28 plus E2. Is negative 28 pretty easy to cut in half? Yeah, so I'm going to go ahead and do that. Be sure to distribute. So half of E2. I'll add 14 to both sides, and that'll be 77 is half of E2. Then multiply both sides by 2. You get 154 is E2. All right, I have a worksheet for you.